Hi everyone, welcome to our session on intelligent prediction, closer than you think. Hope you're having a wonderful day and a great Blueprint 2020. I'm Rajesh Veliyanallore and I manage the science and analytics team at Blue Ridge. Intelligent prediction. In short number of years, intelligence, be it a customer intelligence or business intelligence or you name it, mission intelligence, has transformed from a buzzword or a hype to being a critical enabler to business. It has brought transformational change. In today's session, we will talk about elements of intelligent prediction and share some of the exciting capabilities now and also in the near-term future, what Blue Ridge is bringing into the SAP solutions to help you with your journey to intelligent predictions and thereby enabling you for intelligent planning, which is our end goal, right? So when we talk of intelligent predictions, one thing that right away jump in your mind is autonomous vehicle driving, right? Whether you are in the camp of whether it's safe or not safe, but we can't stop admiring all the great innovation that has gone into where it is currently. And if you look at it, even though it's not related to demand or replenishment planning functionality, but the learnings from the innovation conceptualizes various aspects of intelligent prediction. Intelligent prediction form the core of autonomous driving. Even though there are multiple aspects of autonomous driving, what you will see is basically it has to know whether it's a road or not. It has to know whether it's a person or not in front of the vehicle. It has to know something is moving us. It has to know the traffic lights. It has to know multiple aspects of what it's seeing in front of itself and onto the sides and to the rear, right? So intelligent prediction forms the core of autonomous driving, and in many places they attribute it to be the 80-90% of the work needs to happen in intelligent prediction to enable the autonomous driving technology. In SAP world, our needs are entirely different. But we can see there are many elements of intelligent prediction relevant in our planning world. So if you look at intelligent predictions and look at the facets of intelligent prediction, you will see that improved precision, evaluate options, embedded analytics, advanced algorithm. You can't differentiate whether I'm talking about autonomous driving or even supply chain planning, right? Because those are core elements that are relevant for any prediction and super important for intelligent prediction, right? So the main emphasis here is basically it's not one single thing to come up with a prediction. It has to come up with an intelligent prediction that encompasses multiple aspects of it to make it an intelligent prediction. Not that everything needs to be there, but all of those add an additional layer of complexity and also the superiority of the prediction that we come with. So intelligent prediction is not the end to itself. Intelligent prediction leads to intelligent planning. So when you look at forecast is the starting process for many of the things that is following that, right? So when you forecast with precision, that enables you to optimize your inventory and manage with confidence your business. So when you look from left to right or end to end, if you think of it, the forecasting is like sensing the demand. But it's more than sensing the demand, it's sensing the customer's interest or willingness or what they are after. So get a feel for the customer, right? So sense. And then once you have a good sense of it, that will lend itself to a good plan, which is optimizing the inventory. And that leads to your final act, which is manage with confidence. So the sense, plan, act is the way to move from prediction to planning and with ease. Okay, and those are enabled through the means of algorithms. some of them powerful, purpose-built algorithms that lead your way to move to a better prediction, intelligent prediction. And algorithms by itself is not going to solve the problem. It has to be supported by the analytics and the automation of it. Just the sheer size of the business, the current day business, we don't have time to manage every single item or even a group of items with the level of time that it requires. So it has to automate, scale it, and analyze it, and present the insights so that you can move in an automated decision fashion, and at the same time not lose sight of anything that needs urgent requirement. So when we look at forecasting, which is kind of a, many times we tend to think that basically prediction is same as forecasting. Prediction can happen even outside forecasting, but looking at the forecasting ecosystem, which is the main place where the prediction lands, we think that basically once the sales comes in, somehow magically some black box creates those forecast and seasonalized forecast projection, which is the one that is going to be consumed as part of the replenishment and downstream every place. But there is a whole lot of ecosystem that need to support it to get to that point. So if you look at it, what you see on the right in terms of the demand components or the classification, seasonal pattern recognition, all of those play a big role in making sure that the forecast is good, precise, and dependable. So if you have this kind of some of them are building blocks, some of them are enablers, some of them are futuristic things, but the thing is all need to work together to produce the best forecast that that particular item has. So getting back to our supply chain planning and forecasting and replenishment, these components play a vital role, and within our SCP system, these are our building blocks. Even though you may not touch each and every of those on a daily basis, but these enable you to a better forecast. Okay, so what you see is classification, seasonal pattern recognition, which is the bedrock that is leveraged in forecasting and beyond. But even within the forecasting engine, if you think of it as an engine, there are so many components like anomaly handling, adaptive tuning, prediction, and exception management. In this presentation, we will focus primarily on the prediction and the auto selection part. Once you do all those, the heavy lifting that happens as part of the forecasting process, what you get as the end result is the forecast and the seasonal forecast projection that we depend on for our downstream process. So for today, we will focus on multiple aspects. One is on the managing intermittent and slow demand, which is, if you look at it, basically there are many things that came as part of the release 118, which is on intermittent demand forecasting auto select. And the second component is intelligent min-max. Intelligent min-max is not a forecasting method, but it directly addresses the replenishment perspective. And we will go into the little more briefs. And then some of the things that are coming down the line. It's in the near future, but down the line, in terms of the auto regressive forecasting, neural network forecasting, event or causal forecasting, which gets into the kind of enhancing our machine learning capabilities to provide the best value to the to particular item to make sure that they are done with precision. So now the question is basically the first topic that we are going to talk about is the intermittent, managing the intermittent, what we call it as the tail of long tail items, right? Any business, I think most of you can immediately relate it to your business, saying that, yeah, I have this kind of phenomena where it's a long tail because the long assortment, multitude of assortments need to be supported, some for business reasons, some for perception, some for the real value add. But whatever be the reason, you end up with a lot of items that are selling slow and infrequently. And that's what you would see as a long tail item. So when you look at there will be a few items which is typically like we classify it as a B, C, D items, right? So 80-20 rule will be the predominant factor that you would see. So there are few items that play a huge role in terms of the high volume, more revenue, whatever be the criteria that you attach to, right? Few produce 20% of the items, roughly produce 80% of the value to the company or revenue to the company or profit to the company. On the other hand, you still need to live with the other 80% of the items, which are probably not minuscule in terms of its value add, but relatively a different value add compared to the A items. Those are many, and that makes it difficult to manage. So when you look at the A, B, C, D items, they typically fall into the C bucket or D bucket, right? They are infrequent, very low, kind of a nature. And if you see the industries where you would see that, I would say almost every industry will see that long tail, but different magnitude. But if you look at some of those MROs and the maintenance repair operations or plumbing supplies or spare parts, home hardwares, you will see plenty of items. And you would part of the business, you would know that basically, yeah, that's my struggle. That's my struggle. So this is results from the survey that that has been tracking the what are the barriers to achieving your business goals. And this is the results from summarized from 2019 and 2020. What you see here is basically of all the things that have been listed here, not to say that others are not important, but the thing is the biggest pain point the business sees, especially the wholesalers, distributors and wholesalers, right? C is the slow mover management. Why is it difficult? Multiple reasons. So it's difficult and challenging to forecast. It's difficult to plan. It's difficult to make the inventory lineup. So in terms of the forecast, you would see that they are too reactive to demand, and most of the demands are zero demand, right? So you have very infrequent demand signals. Sometimes it happens. Most of the times it's zero or no sales happens. And every time there is a no sales happen, it's a signal, but not a signal to the level of demand happening. But the thing is, the traditional forecasting systems tend to get the forecast closer to zero as they see continuous zeros happening period after period after period, right? So this is a phenomena that you would see where the red line is the bar graph is the demand. You will see more of many zero demand periods. And the red line is the one that is the smoothing, exponential smoothing based method, right? So when you generate the forecast, when you see a lot of zeros like period 8 to 13, you see the forecast tend to get to zero. And once it sees the demand, it will jump up. So that close to zero forecast and jumping up of the forecast creates a lot of instability in the forecast when you're looking at the projections, right? So it also creates a lot of trivial exceptions. Nothing you need to do, but still it throws an exception. So typically we ignore that, right? And because of the non-normal distribution pattern that is emerging out of these kind of items, a biased forecast error metric creates a wrong sense of satisfaction in terms of this safety stock. So what you end up with is too much or too little inventory. What I describe as you have a feast or a famine circle. So the first thing that you would see as part of the release 180 is the intermittent demand forecasting. So instead of treating it as like a typical every continuous selling items where the exponential smoothing methods tend to do much better, intermittent demand forecasting exploits on the demand pattern that is there, right? Once you know the demand pattern, once you understand it, you can take advantage of it to give a better forecast. So here the demand hits and the varying spaces are treated as two different demand series and separately forecasted and then combined back. Once you have that kind of a separation between those demand magnitude and the time between the demand and combine those back, that provides a lot of stability in terms of the forecast. So what you see here, the red dotted line is the forecast that you typically get from an exponential smoothing method, but the green line is the forecast that comes out of the intermittent demand forecasting method. What you would appreciate here is there is a stability in forecast. Even periods of zero, it's not changing the demand forecast drastically because it's looking at a long-term history and has the vision about, oh, okay, I don't expect zero demand to occur every single period. So there is an extended period of zero, it understands it. It doesn't artificially tend to overreact to it. So the prediction is based on the broader view of demand. And the significant thing that I would highlight here is it incorporates seasonality into the forecast. So if that item, just because it's a slow moving item and intermittent selling item, doesn't mean that it cannot have a seasonal pattern. So you might have some items selling only during the certain periods of year. In those cases, if there is a seasonal pattern that is there for that particular item, it incorporates that so that it doesn't plan for a peanut butter spread across the projection of same number of forecast units throughout the year. It appropriately allocates the forecast or uh, indexes it to make sure that the seasonality is accounted for. It also allows you to have a better safety stock control because it's just not dependent on a normal distribution. It understands that basically those two patterns are different. You can continue to have the user intervention. Things change, business changes. So the buyers have additional information about certain items. Those information that are not reflected based on the history, the buyers can continue to intervene and accommodate those business changes. It significantly minimizes the non-value add exceptions, right? So we talked about the infinity exceptions, which is typically thrown as part of the AES forecasting, where you have a lot of exceptions, you don't know what to do with that. Typically, most often it's ignored, right? So why to have it? It doesn't add value. If it says something, then it makes perfect sense. But the thing is, basically, it's of no additional value. So it significantly minimizes those exceptions. And on top of it, it achieves a better forecast accuracy, right? So you continue to have all the benefits of a forecasting technique with improved forecast accuracy, specifically built to treat intermittent demand forecasting items. I'll take it. So what's intermittent demand forecasting is by itself is a forecasting method, like a adaptive exponential smoothing method, right? But what makes it special is the auto select feature that is there. So what auto select allows you is basically you have an expert system sitting on top of the forecasting methods that governs and rules the engagement through the data-driven approach. So if there are multiple forecasting methods eligible to generate, so when an item is qualified to have intermittent demand forecasting, it also generates a forecast using adaptive exponential smoothing, your bread and butter that you've been used to for ages. And this auto select is the one that is going to say, okay, you do the best, but I will govern based on which provides you the better forecast, right? So all forecasting methods compete for a forecast best pick feature. And the data-driven approach, where it evaluates based on the forecast accuracy metric like MAPE during an optimal window, which is the recency window, and then makes a selection in terms of which is the one that is a better performer. So in this example here, you see the picture down. There's a forecast method 1, forecast method 2. Both goes through the same process, generates it independent forecast. The auto select is the one that's going to see, okay, which is the one that is doing good. I will look at the MAPE accuracy, which has the higher accuracy. I'll promote that and automatically apply without any intervention by the buyer required. So switching gears, we are going to talk about something different in what we call as intelligent min-max, right? So intelligent min-max is not a forecasting technique, but it's going to help intermittent slow moving selling item to set the right appropriate replenishment controls. And when we talk about controls here, we are talking about low stock point and order of delivery, which are the governing things, right? Min and max. Don't go below this, don't go above this. Those are your controls. So it's a fundamentally different approach to deal with the intermittent items. What it does is basically it takes a Bayesian approach. So what it, in simple terms, it means it doesn't depend on a distribution. It doesn't assume a normal distribution or a uniform distribution or any of those distribution. It can perform for a wide range of items. And because of non-parametric and ensemble based, it is much more robust. So it says that, okay, forecast cannot do a better job on this, and let me not try to deal with it in a forecast approach. It directly looks at the history and comes up with the mins and max. And what it helps is basically making easier to auto manage the long tail. So intelligent min max. When you look at it, it's going at looking at the classification, which we talked about as the leveraging part. Demand history, service target. Yeah, item with a 99% has a different expectation than an item with a 80% service target. So it has to account for that. And the lead time and the order cycles. All this it uses to look at the eligibility analyzer, because it has to learn from the history. Does it have enough history? Does it have enough information in terms of the non-zero demand history? So based on that, it will proceed to calculate the mins and the max for the items. So what comes out as basically, I have the eligible information to go proceed to calculate the mins and max. It will calculate the min and max. Doesn't mean that basically it's going to apply it, because it's going to have the guardrails to validate based on user overrides, just to make sure that it's not double counting on anything, right? So if user is in control, then you don't want to double count on it. So it will validate that. Once it passes through the guardrail validation, it modifies the low stock point and order up to level automatically. The good thing is basically the mins and maxes are refreshed automatically as well. So you don't need to go through the cycle of calculating the min and max. It will calculate, it will assess the eligibility, it will calculate when it's eligible to proceed, calculates the min and max, knows when to apply, automatically applies it for you. And what you end up with min and intelligent min max is it addresses the hard to manage inventory and service, because it's coming from a different perspective altogether, not in terms of improving the accuracy of my prediction forecast, because it says that, okay, forecast is no good. I need to find yet another route to the destination. So it looks at service. Services is primary goal, and how to improve service. That's its primary motive, and it works to address that problem. So inadequate inventory, missed service, missed margins typically are the ones that you will see the biggest benefit in terms of the intelligent min-max, right? It's replenishment aware, so it knows where to apply the low stock point and the order up to level. It already knows the service goal, and it makes managing business efficiently, right? There are times where if the inventory level is not appropriate at the current level, it will increase the inventory level, because for you to support the service goal, if you need a higher inventory level, absolutely it will do that. But its perspective is more in terms of in-stock and service level. And what we have seen in terms of the past experimentation is service improvement. We have seen at least 2.5%. When you say at least 2.5%, the reason is for intermittent items, you need to study over a long time, right? So the chance of having a demand itself is very low. And for you to have enough amount of data to calculate that, you need to have a longer time. So the initial assessment is basically 2.5%. And once you look at for longer time, it will be much more than that. So it's a service improvement lever, if you think of it, intelligent min-max, to better serve your customers. So now I'm switching gear to the second part of my presentation, which is I'm talking about the enhanced machine learning. And the things that we talked about previously were the ones that were part of the release 180, and the ones that I'm going to talk about now are not part of, it's going to be sometime future. right? I just want to make sure that it's completely clear. So it's upcoming sometime in the future. The product outlook presentation will provide more insights in terms of the timing aspects of it, right? So auto regression ARIMA forecasting, right? So now we are moving from away from an exponential smoothing method to a new class of method, which is kind of a machine learning embedded methods now we are getting into, right? So which generates forecasts using a linear combination of past demand values, not just one demand period. It attaches the right weights that it needs for the few past demand data to come up with a better forecast. The end goal is the same, kind of a better forecast. So what it does is it analyzes the data, it finds the patterns that are there in the data, and sees what is the level of autocorrelation. What it means is basically how much of the next value is dependent on the previous value or previous to previous value. So it looks at combinations of it, comes up with the weights for the different demand lags, takes care of the anomaly correction, seasonal handling, and forecast validation, and comes up with a forecast, right? So the weights are optimized than a fixed weight that you would see typically in exponential smoothing method, which is the biggest value add from that, because it validates and looks for the right weights and applies it for it. And those weights are automatically calculated and refreshed on a particular cadence. So you are always in sync. Okay. Then the results speak for itself. So when we apply this auto-regressive forecasting to several of our customer sample data. So across this 7 customer sample data that we are talking about, we are talking about a good chunk of items. It's a fast-moving items relatively. That's where these methods are applicable. We are talking about 150,000 plus items. So it's not a minuscule sample. It's broad across multiple industry and multiple domain, right? So what you would see is this is the accuracy improvement on top of what a AES forecast can provide for these items. So you see 1 to 4% typical accuracy improvement. Some might have a little towards the 4, some might have towards the 1, but across the board, the median improvement in forecast accuracy is appreciable number. So the next one is neural network method, right? So we talked about AR forecasting. Now the neural network method. Neural network, kind of you would automatically know that basically it's a machine learning method. What it also does beyond any other traditional method is basically it allows for understanding the non-linear patterns in the demand series. A typical method, even ARIMA method or even the exponential smoothing methods, look for the linear patterns. Once you allow the non-linear patterns, you widen the spectrum of understanding the problem, right? So it effectively blends in all those short and medium term demand patterns to come up with a better forecast. So what you see on the graph to the right is there is an input layer, which is the historical demand patterns, right? And there is a hidden layer where most of the magic is done. In terms of the building blocks of the neural network is coming from how the brain works, right? We somehow, the eye see it, the body reacts to that, the brain understands it. This is the fundamental principle in terms of the neural network, and that's the hidden layer. That is where the most of the power comes in from. And then the output layer is the forecast that we are talking about. So here as well, the weights are automatically calculated. It's optimized, it's calculated, it will generate the forecast for you, looking at all the historical patterns, right? So what you see, just like ARIMA forecasting, when you look at the neural network forecasting, 2 to 6% accuracy improvement. Same set of items that was used in ARIMA comparison, we are using it here, 150,000 plus items across 7 organization represented by multiple industry. It's 2 to 6% accuracy improvement, right? So the overwhelming support in terms of the accuracy improvement is kind of it's unambiguous. So this is a little different contrast to the same problem to say that Autoregressive, what we saw is 1 to 4%, but if I look at the average accuracy improvement, it hovers around 2.5%, which is not minuscule, which is good, 2.5%. Neural network in isolation, I'm talking about just neural network, achieves the 3.4% average accuracy, right? But if the neural network and autoregressive are allowed to compete against each other, let the best one prevail. We talked about the auto select, where it will pick the right forecasting method. Let them do their work and let us pick through the auto select what is the right one. You see an additional increment to 3.9%, so 0.5% more than even a neural network method. So this talks volume in terms of those methods in individual, but also the auto select, which takes the best out of those. So you would have been used to this in terms of the adaptive exposure smoothing, right? We have continuous items. What you see on the bottom towards the x-axis is basically the new item or continuous item, intermittent short life cycle. Short life cycle is basically you sell items, the demand occurs only during certain parts of the year. Other periods it's more like intermittent, right? So the demand rate can be slow, medium, fast. So when you're looking at it, when you're in the adaptive exponential smoothing world, which we are kind of till now, you would have been using adaptive exponential smoothing for everything. You will assign adaptive exponential smoothing as one de facto forecasting method for every single item, right? Now you have a choice. Once you enable IDF, then that begins to compete against, in some of those cases, these methods are purpose built. It's not a general method like a AES method. It's a purpose built in the sense it is applicable only in certain circumstances. Or the right way to say is basically its value add is much more pronounced in certain circumstances. So for the intermittent and short life cycle that are slow and kind of a borderline medium, those perform better with IDF. So in those spectrum, IDF will compete against AES and the better one will prevail. There is no preordained forecasting method when it comes to IDF or any of those additional forecasting methods. Same with neural network and AR. They work on a space which is a continuous item because it needs more information, right? It's a machine learning and needs more information. So neural network and AR work on a continuous spectrum of items that are fast and medium. And that's where they compete and produce the results. The results that we shown in the previous slides pertain to that region of those item classification. So the last thing that I have today is causal and event forecasting. So when you look at event promotion lift calculator, there are a multitude of reasons to come up with what's the lift beyond the base forecast that is there. And the influences for the demand might be because of multiple reasons. One might be the price, which is the normal case, but there might be promotional attributes or event, which generally we call it as a causal and event promotion. So interchangeably we use it to most extent. So there are multiple reasons behind why certain demand qualities happen. And the causal forecasting, what we are envisioning is in terms of attacking all those things, in terms of the price changes, in terms of a promotional event, in terms of any influences, right? Supporting any of the influences, which are multi-attribute and have the ability to select which are the attributes that are of importance. So when you throw multiple attributes, there is a feature engineering that allows it to crunch all the data and select which are the ones that are important for the prediction purpose, right? And then leverages the machine learning and recent event look back to validate to come up with a lift. And this lift can happen, this lift calculation can happen for a short duration event, for a long duration event, and pre-post event uh, dip of dip in promotional impact as well. So the end goal is basically crunch all those information, do the feature engineering, limit the number of attributes that are meaningful, generate the causal forecasting, generate the causal lift. And once you have the causal lift, you can generate the causal projection based on when the events are going to occur in the future. And as you proceed in time, and when those events really happen, you can also have the causal yield analyzer, which is more in terms of this is what I expected, this is what really happened. Now, what are the net differences? Right? So those capabilities are something that we can bring to supply chain planning in the future term. So I've contrasted in terms of the things that we have currently, which is on the IDF and the IMM part, and things that we are going to uh, in the near future term, right? I just want to give a flavor of what's to come so that you are better prepared for that. And that's the end of my presentation, what I have planned for today. Uh, if there are any questions, always feel free to reach out to me or through the customer services. Uh, the goal is basically to make sure that basically we have the best in class to make you perform in the intelligent, get into the intelligent planning space through the intelligent prediction space. Hope this was useful. Thank you. Have a good one. Enjoy the rest of the conference. Bye.